someone could potentially just go to the toilet, a place that is not monitored at all because there are not cameras, of course, inside the toilet. You cannot put them there, and manipulate something inside the train network.
Welcome everyone to the Industrial Security Podcast. My name is Nate Nelson. I'm sitting as usual with Andrew Ginter, the Vice President of Industrial Security at Waterfall Security Solutions. Andrew's going to introduce the subject and guest of our show today. How's it going?
I'm very well, thank you, Nate. Our guest today is Mickey Schiffman. He is the Chief Technology Officer and co-founder at Silas. And our topic is cybersecurity for rail systems, harder than it sounds.
Okay, well then without further ado, here's you and Mickey.
Hello, Mickey, and welcome to the podcast. Thank you for joining us. Before we get started, can you say a few words about yourself and about the good work that you're doing at Silas?
Hey, Andrew, thank you for having me. It's a pleasure to be here on the podcast. I'm really excited towards it. So my name is Mickey Schiffman. I'm CTO and co-founder at Silas. So we founded Silas in 2017. Prior to founding Silas, I served as an officer in an elite technology unit in the Israeli Defense Forces and dealt mainly with cybersecurity, communication systems, embedded systems, and everything in between. Within Silas, overseeing product and technology. And in Silas, our mission is to protect railway systems all around the world from cyber threats. We'll explain later on why is it even a topic. And other than my work at Silas, I'm also contributing to various cybersecurity working groups in the rail field worldwide. The latest is actually an IEC group that's currently working on developing the latest standard for rail cybersecurity, something that should be published over the next year. And we're looking forward to it. It's supposed to be an important milestone for rail security worldwide.
And our topic today is trains. It's rail system cybersecurity. We've had a couple of guests on the show some time ago talking about rail systems. Can you remind us, what is a modern train? How does it work? How's it automated?
Yeah. So before digging into how the trains actually work, I want to put a few facts here just for the audience to get more familiar with the operating constraints. So first is that trains can operate in speeds that are over 300 kilometers per hour and have a stopping distance of 1 kilometer and more sometimes. The reason I'm mentioning that is to explain that only automation can enable that, because a normal driver cannot really see in such a distance, and of course in such a speed you cannot really notice the state of the signal. So you need to have something that transmits the information to the cab or makes decisions on your behalf. A second thing is that you have more and more services for passengers, and that results in modern trains and of course the safety constraints and the requirements for high availability. Trains are now many times have hundreds of connected devices in a single train, and they communicate with each other through safety critical and non-safety critical communications. Other than that, you have wireless links, so a train operator can sometimes have a huge wireless network. In Europe, it's GSMR for positive train control. They use many times the 220 megahertz radios, and other signaling systems have other wireless modes of communication, such as CBTC, which is used for metro, many times uses just Wi-Fi. And all of them together as a single system cause the train to be heavily reliant on technology, and this technology is very proprietary and used only in rail.
Let me jump in here and give just a bit of background. Mickey used the word signaling a couple of times. In the old days, what was signaling? In my dim understanding of it, it was an electrical process. If a train was on a segment of tracks, it closed an electrical connection between the two tracks. And so you could sense that, hey, there's a train on the tracks, or, I suppose a metal bar could have faked it out, but you've got you've got electricity, a small amount of it, a signal moving from one track to the other. And this told a light at the beginning of that segmented track to go red, saying there's a train on the track, you have to stop. And it was, similarly electrically connected to the previous segmented track, so that the light at the beginning of the previous segment went yellow, so that an engineer driving another train, sitting in the locomotive, coming up on a segmented track, if that engineer saw a green light, and I might have the colors wrong, but let's use the traffic light convention. If the engineer saw a green light, knew that the next two segments of track ahead of them were clear. If they saw a yellow light, they knew that the next segment ahead was clear and the one after was not. If they saw a red light, it was stop now. You've got something on the tracks ahead of you. This was old school, and it relied on the reflexes and the attention of the engineer. Nowadays, it's all been automated, and the buzzword is positive train control. Train control basically means you get a signal from computers saying which tracks are clear, which tracks have locomotives on them or trains on them, and the computer in the locomotive it brings the locomotive to a stop if it needs to. Positive train control means that it's not a stop signal that is sent to the locomotive by the computers. It is a go signal. And if the computer in the locomotive ever fails to get a go signal in a given amount of time, it immediately stops. That's what the positive in the positive train control means. It means you continue moving only if you continue getting a positive signal saying the road ahead of you is clear. So this is sort of the modern world that it's all automated. These are safety critical environments. There's challenges in terms of being able to see what's coming down the track, stopping these very large, very fast trains if there's an issue. How does that relate to cybersecurity? What are sort of the unique challenges for cybersecurity in the rail systems?
Yeah, so the main aspect of a rail system that is quite unique is the long life cycle. So a train can be operated for 30 years. Usually I give the analogy of we can think of what we knew about cybersecurity 30 years ago, and that would approximately be the level of security that exists in many of the current trains that are in operation. The other thing is safety. So to achieve this high level of safety and making trains the safest mode of transport, you need to have a lot of constraints. And many times those constraints, they come in conflict with security. So just an example, in many countries, in order to patch a device on a train or a safety critical network, you need the government to sign off the patch. And that can take just months of approval from the time that you even have the patch available, sometimes years, sometimes you just don't touch it because it's so hard to change. And you don't want to go through this costly process of updating. The other is that train manufacturers and the technologies used in trains, they're many times really dedicated for the rail industry. So they're not used in other industries. You have technologies that just have been developed for a single industry. And the know-how in the industry doesn't necessarily contain a lot of cybersecurity. It's mainly around safety and operations because these used to be the core values of those systems. Other than that, you have passengers on those trains. So although it's a critical infrastructure, it has high interfaces with the public. And people can be on trains, they're in stations. Trains are moving, so they're not in a fixed location that you can kind of protect or put walls just to protect it. And all of those are quite significant challenges that the industry works around in order to improve the security of those systems.
So a clarifying question. It sounds like you're saying if, when passengers come into a transit, car or a commuter car, it sounded like you're saying some of the computers are there exposed, or are the networks exposed? In what sense is this automation exposed to the public, and how big a problem is that?
Indeed, of course, not in all cases. In many cases, it isn't. Indeed, there are cabinets that are exposed to the public, and I can give a few examples. And some of them, you can see them in train stations. They use just a key that everyone can buy online, and you can see them like monitors on trains, and as I mentioned, in the stations themselves that are like that, and someone could potentially abuse. The other example, which is a bit more, let's call it exotic, was something that we saw in some trains, that apparently the toilet computers or the systems that are responsible for mentioning the state of the toilet to the passengers, like whether they're occupied or not, they're connected to the network of the train. And they are just communicating in a bus with all the other devices in the network. One interesting thing about it is that sometimes either their controller or other controllers, there are architectures in which they are located inside the toilet cabinet, for example, behind the mirror. And in such cases, someone could potentially just go to the toilet, a place that is not monitored at all because there are not cameras, of course, inside the toilet. You cannot put them there, and manipulate something inside the train network. So this is actually a scenario that we've seen happening, at least in some attack simulations, and it was actually executed by the ones who simulated those attacks.
Let me give you just a little background. In my understanding, modern passenger trains have not one network automating the train, but three of them. There is obviously the control network where the positive train control happens, and other kinds of control functions on the vehicle. There is the entertainment network, because a lot of the modern trains have Wi-Fi. They might have an internet connection, that you do or don't have to pay for. They might have movies you can watch on long rides. And, of course, people are connecting their cell phones and their laptops and their tablets to these entertainment networks. And there's what's called a comfort network, which is focused on, automation that involves the comfort of passengers, like are the washrooms occupied, what's the temperature in the cabin, control the air conditioning, control the, if you've got on the truly modern cars, the opaqueness of the windows so that the sun isn't blasting in on you, the lighting, if it's at night, this kind of thing. So, and these networks, you generally want to see, you want your passengers to be able to see where you are, and, a very small amount of information that's coming out of the control network that's tracking location and other aspects. So, how are we late? You generally want passengers to at least be able to see what's going on comfort-wise, so they know, which restrooms are available and how many cars they got to hike down to find one. But you should at least have firewalls, if not, unidirectional communications between the more critical networks and the less critical networks, certainly in the entertainment network. Older systems, older rolling stock may not have these distinctions. They may have mixed up some of these networks that are more separate on the newer stuff. It's a mixed bag out there.
The kinds of trains that I've had experience riding do not appear, at least from the passenger perspective, to have all of these comforts and amenities. Is this common?
I believe it's common in the newer vehicles, the newer rolling stock. But if it's not there, sorry for you, it would have been nice to have a movie on the ride. B, if it's not there, it also means you don't have any of these risks because it's not there. So, it's a mixed blessing. It reminds me that very recently we had a scenario in Poland where we saw a bunch of trains, like 20 of them, I think, suffer emergency stops because of some hacking attempt. Can you give us the details there? What happened there?
Yeah. So according to what's known to the public, what basically happened there was that there is a legacy system that is in used for train communications in Poland. And this system is receiving or capable of receiving wireless signals. And those signals are effectively subtones. And a specific sequence of those subtones can make a train stop. And that's by definition, by design. So I want to talk about a few points related to this case. One of them is the use of wireless communication. It's not very trivial that critical infrastructure uses wireless communication so heavily as rail, and that's a unique attack vector in rail network that should be secured as much as possible. Not necessarily there's a lot of things you can do in such a situation, but it's something to be considered. Here specifically, it's a very old system, but even if it would be replaced with a newer system, those systems also rely on wireless communication, and these are also digital wireless communication. So it's even more susceptible to attacks because you can do a bunch more other things. Many times those wireless communication links are not properly encrypted or using old encryption or no encryption at all. And these are interfaces that should definitely be looked at, and protocols like ERTMS or CBTC, there are different potential security challenges there. The other thing is more related to, let's say, motivation. And that's something that we're seeing now along those geopolitical disputes, but real systems are a high-quality target for threat actors. And the people within the rail company, the operators, they are responsible for ensuring that the public is secure in those systems. And what we are unfortunately seeing here is threat actors are increasing and setting their sights on those rail systems and showing the motivation to attack them. And in my opinion, it should be a wake-up call to many people in the industry that not necessarily looking at security. Not necessarily in this case, by the way. That's just an example of one company that got targeted, not necessarily even by cyber attackers, but over wireless radios. But in general in the industry, I think that we should look at the fact that threat actors are actually looking and inspecting those systems, and they can be aware of many of the specifications, and these systems definitely should be treated with security in mind.
The latest numbers in the 2023 threat report on OT cyber incidents show that the threat environment has changed fundamentally at the beginning of this decade. OT cyber attacks with physical consequences have changed, from a theoretical problem to a very real problem, more than doubling every year. The new report is focused on deliberate cyber attacks in the public record. These are attacks that cause physical consequences in process industries and discrete manufacturing. Most of these attacks are ransomware, though the fraction of hacktivist attacks is growing. And the report's appendix includes a complete list of all cyber attacks since Stuxnet that meet these criteria. To see how today's OT cyber threat environment has changed, I invite you to download the report, a joint effort between Waterfall Security and the ICS Strive OT Incident Repository. You can download the report at waterfall-security.com/2023-threat-report, or just go to the resources menu at the Waterfall Security site and click on white papers and ebooks.
So Nate, let's talk about wireless communications for just a minute. Most heavy industry is deeply suspicious of wireless, any kind of wireless. Why? Well, it's because cell phones are walking wireless attack vectors, among other reasons. How does that work? Imagine that, your pizza delivery guy has downloaded a Trojan game, delivers pizzas into a refinery or a power plant. And the Trojan game, while it's inside the power plant, is scanning for Wi-Fi networks and reporting their geographic location to a command and control center. Now the bad guys decide they want to target a particular power plant. They know in their database, they've got, 6 Wi-Fi networks in that plant. One of them has the name Control. The other one has, suggestive names. They launch a phishing attack. They steal the credentials to log into those Wi-Fi networks. And now the next time anybody carries the compromised game on their cell phone, doesn't have to be the same pizza delivery guy, it can be anybody carries that a compromised cell phone into the site. The bad guys can connect to the cell phone over the cellular network, operate the Trojan on the cell phone, give the credentials, connect to the Wi-Fi network in the site, and work their will upon it. So heavy industry is deeply suspicious of wireless for this attack scenario and many others. The problem with the rail system is that you have no choice. You have to use wireless communications to communicate with these locomotives that are traveling at 300 kilometers an hour, all over the countryside. You have no choice. And so, yes, you have to encrypt everything. Yes, you need credentials everywhere. And you've got to train your people not to leak these credentials because, there's just, so it's a hard problem. You have to use wireless, but nobody wants to. And so there's a lot of focus on wireless security in the rail system. That's a distressing picture of sort of constraints and issues in the security in rail systems. Can you talk about sort of what's the response? What's the industry doing to address these things?
Of course, the topic of security is quite broad. We know it from all other industries as well. And there are a few motions there. One of them is securing the install base. The other is develop products that are trying to be secure by design. And also in each one of them, you can dig deeper and see the controls that are being used in order to achieve those purposes. So there are some controls that are harder to use many times, like, for example, encryption is not necessarily being used in the industry for other reasons. It can be about latency and potential impacts on the operations. Other than that, you have methods of things like segmentation, in which we also cooperate with Waterfall, and solutions like diodes or firewalls as such. What we're doing is another thing, which is being non-intrusive and trying to be as much easy as possible to deploy. So as I mentioned before, the main constraint in the rail environment is safety. So you are trying to secure as much as possible without compromising safety and operations. And that's not such an easy task because in order to secure optimally, you, of course, need to make a lot of modifications. You would like to maybe change the devices themselves. As I mentioned before, you might want to introduce encryption wherever it's possible. But sometimes what we're seeing is that making those changes is much more expensive in total cost than just introducing an external solution that will give you the right compensating control over the fact that those controls do not exist. And when I say expensive, I mostly mean to the need of recertifying the systems, passing them through safety approvals, upgrading the huge install base, etc. And our approach in Silos One was to help operators to be able to meet the best security practices and follow the security frameworks in a way that is tailored for their environment, as well as make sure that all of those processes are indeed aligned with the safety processes and are not introducing another risk or challenge with that regard.
Okay, and in terms of solutions in this space, Silas is, you folks, have services offerings. You've also got technology. You're selling technology into this space. What are you producing, and how does it work?
Our solution, Silos One, which is the solution that the company develops, is what we call a Railtech security platform. So a Railtech security platform is a comprehensive platform that is capable of providing several benefits to operators. So the most important thing about this type of a solution is the context that it has. So we haven't invented the space of operational technology monitoring, but I think that the major innovation that we bring in the rail industry, and it's so much needed in the rail industry, is the ability to put context around the information. So our ability to provide operators with visibility, which is precise and is tailored for their environment, so the ability to differentiate between assets, whether they're safety critical or not, whether they're interlocking light signals, point machines or things on the onboard, such as braking systems and door control units, this ability helps them to actually identify their environment, understand the exact status of their security posture, and also remediate security issues as they occur in a much faster pace because they have this context. Think about it. If you could have a network of hundreds of thousands of devices and you don't really know what's the role of each device, it's very hard for you to prioritize whether an alert is severe or not, understand who's the owner of a specific device and who should treat the security issue, understand the context of the device in the broader rail system and whether operations can continue as normal or not. And these are all things that our solution brings. So broadly speaking, our solution helps with visibility, with detection, the response piece of it, which is very important because detection is one nice thing that you can do by detecting various sorts of tactics, techniques, and procedures. But understanding how should you properly respond under the constraint of the rail environments is part of our secret sauce and part of the value that we bring to the customers to make sure that they're not just lost and flooded with lots of alerts. And also, of course, compliance, because compliance is paramount in the industry. So the ability to comply with rail security frameworks, as well as security best practices while meeting the safety constraints, these are all things that you get through our product. And it helps you to also, of course, meet the requirements of all the latest regulations, such as the TSA directive in the US, the NIS2 directive in Europe, and standards and best practices such as TS 5701 and IEC 63452 that will be developed, that will be released in the future, and the system, of course, will also help operators to comply with it.
Okay, so that's a lot of benefits. These are all important benefits of a solution, but you haven't really said how it works. I mean, if you want to understand sort of the purpose of each piece of equipment, do you enter its IP address by hand and enter the data by hand, and now you have it available when an alert comes up? Or do you discover this stuff automatically, or what? I mean, how are you gathering this data, and how much of it is sort of manual? How much of it's automatic? Can you lift the hood for us?
Yeah, that's a great point, Andrew. Yeah, I'm trying not to expose too much the tech inside of me. So yeah, that's a great question. So there are several ways that it works. First, as I mentioned, the purpose is to be as much non-intrusive as possible. And the way of doing it is first, like, we collect information via network traffic. So we passively connect to the network via taps or span ports or diodes, what is approved by the customer, and collect the information passively through our platform. That's raw network traffic, and we extract the context that I mentioned through this raw network traffic. So it starts by analyzing the protocols, which is probably the easier part, but then it builds up over our algorithms for asset database and anomaly detection and compliance and helping actually to make sense out of this data. So that's one source of data that we treat. The other source of data comes from integrations. Integrations can be through operational systems that exist in the environment, and these operational systems already gather insights about the operational state of the real environment. This can be like maintenance systems, for example, and our system can seamlessly integrate with them. And by collecting this information, users can get a single pane of glass over their operational and security data in the sense that when security data is out there, you can actually correlate it with the operational info that you have in the environment, and that usually helps you to spur false positives and have shorter investigation cycles. Other sources of information can include asset management databases, risk management databases, other security solutions that are used in the networks, whether in the endpoints or other locations. And we collect information from all of those in order to put this information into the context that I mentioned before. So with these capabilities of information collection, you can actually get a very comprehensive view of your network and very precise view of your environment, whether it's trackside, onboard, in the operation center, or in the stations themselves.
So listening to this, I think some of our listeners might ask, why the great focus on detecting and responding to incidents. If cybersecurity is critical to safety, then do we not need to prevent the incidents? I think the answer is partly we got a lot of legacy equipment out there. It's weaker than we want it to be, and so one of the compensating measures we can put in place is a strong detection. It's not as good as changing the systems to prevent attacks, but it's something that, especially in a passive mode, it's something we can very quickly add after the fact without arousing the ire of the regulators, the safety regulators. You might also, and don't get me wrong, you might also ask, well, if we were able to prevent these attacks by applying security updates, by doing better segmentation, by whatever. Could we, do we then still need detect, respond, and recover? And, the answer is yes. We need both. The NIST cybersecurity framework has 5 pillars, and you don't choose between them based on your industry. You might prioritize them based on your industry, but a robust security program has all of them. The most sophisticated intrusion detection, the most sophisticated, detect, respond, and recover programs that I've ever seen are at sites that also have the most sophisticated prevention programs. They sort of go hand in hand. So, on the one hand, it's a compensating measure. You can get some of your assurance back with detect, respond, and recover. And on the other hand, it's a long-term investment. We need it going forward. Could I ask you to go maybe a little deeper on response playbooks? If there is something that might be an incident or definitely is an incident, it sounds like you have some support for dealing with the incident. So can you speak to response playbooks? And you've also mentioned compliance. It sounds like you can compare what you're seeing to what needs to be there compliance-wise. So can you talk about sort of response playbooks and compliance? How do you do that? What does that look like under the hood?
Let's start with response playbooks. So in response playbooks, our goal is to have the operator capable of handling our alerts in a way that fits their environment. So it starts actually by helping the operator to get all the relevant context over a specific alert. So it's the ability of identifying similar alerts very quickly and correlating it with them. It's the ability of understanding whether maintenance activities took part of over a specific asset. It's the ability to see what other things this asset has experienced prior to this alert. And it's basically this and others that create the context that helps the operator to first understand whether this alert should be there or not, whether it's expected maybe. And it also afterwards helps them to adjust it accordingly, so adjust the sensitivity of the system and ensure that they will see more or less of those alerts in the future. Other than that, there is the part of, by identifying the context of the alert, the context of the asset, the context of the operations, understanding how do you actually should respond to this event. And by responding, you can take several actions. Some actions will be hard to take over a specific type of system. Some are more possible. Generally speaking, the industry is just starting in terms of like the active response capability, so the ability to actually like micro-segment or do something similar over assets. It hasn't been the case until now, but we see more and more sparks of it, specifically in specific systems that are inside the industry. And this general ability of like providing the operator a context, it spares a lot of time. It's something that you can effectively measure by the time that your SOC team or your operations team needs to take when it analyzes alerts. And I think that's an important metric to look at when you're having some sort of a SOC and rail company, or you're setting up this monitoring or detection program inside your company. And that's where context is mostly useful. So that's about the response piece in a nutshell. If we go into compliance, so compliance is a very broad topic. And especially in rail, it has a lot of tailwind coming from the different standards that are being developed and the suppliers themselves, because the industry is used to develop things that are certified to something, and that's the stamp that the industry provides to their components. So the general, let's say, major capability of the major rail suppliers is the ability to have high level of safety and certification, and that's very hard to achieve. So what we're seeing more and more is that the trend in the industry is to have a similar approach with security. So to ensure that there is a baseline of security that is by design in those devices, and ensure that it's being enforced over those devices. And this baseline of security can be a standard like IC 643-3 family, which is more of the system integrator side. And it can be something around IC 643-2, that is coming more of the asset owner side. And all of those together are being embedded into this new set of frameworks that is developed in the industry. And what our solution helps with is the ability to first understand your compliance status to some of the requirements, at least those that are related to controls, because many of the requirements are also related to processes, which are not necessarily things that are visible through just monitoring of traffic or analysis of data. And other than that, it helps you to understand like your general level of compliance to a specific framework, where the system helps you to achieve the goals that you have on specific requirements. And that's something that can also serve potentially as a competency control for requirements that you don't have, because the truth is it's very hard to apply security to especially legacy systems, but the term legacy is really stretched in the rail domain because it's 30 years. So even if a system was developed like 5 years ago, it's already legacy and doesn't necessarily include security by design. And with our product, you can actually look at the different parts that you're not compliant with and see what coverage you can actually achieve through using the solution. So for example, if you have an unencrypted link, that's bad. Like that's not something that you would like to have. But let's say the second best of like encrypting it or authenticating it would be probably to ensure that there is no abnormal communication over the link that could potentially compromise you. Because it's one thing to know that you have a risk, the other thing is to actually be able to mitigate it or identify whether this vulnerability is being exploited. And that's something that we can definitely help with to the operators that are trying to meet those frameworks, even with partial ability to implement controls.
So I'm still a little confused on the compliance side. Can you give me a couple of examples? What kind of things can you detect on the compliance side and report on?
Maybe just to kind of like go back to the previous question and start from there. So another important aspect of compliance is what happens the day after a system is being handed over. So most of the compliance or most of the frameworks are focused in complying at a certain point of time, which is usually the handover time from the system integrator to the asset owner to the rail operator. And from that point, it's under the responsibility of the operator, but it's very hard to enforce it over time. So even if there is a configuration that took place initially in a good way, over the lifespan of 30 years, that could be changed. So, for example, I mentioned before the idea of vulnerabilities and patches. And one of the things that you can potentially do is to actually, like, through your vulnerability management and patch management program, you can track the vulnerabilities of your devices and ensure that the patches that needed to be installed based on your patch management program, which is adjusted to your environment, adjusted to the safety constraints, are actually being installed. And that's something that is essential because you're probably not going to end up installing all the patches, but you're going to end up installing at least part of the patches that are needed in order to meet your objectives. And that's something that we can actually track automatically, so the vulnerability side, and also the installation of patches and the software versions of the devices. So that's one thing. The other thing is actually more exotic examples of like systems that haven't been properly segmented, large systems. And one of the challenges that the operator had that they wanted to kind of like divide the system into security zones and conduits, like in the IEC 604 terminology. So this requires you effectively to install, of course, some segmentation appliances inside the network. And they had them in several occasions, but several occasions they didn't have. So one of the things that we could help with through our virtual segmentation capability was actually to divide automatically or provide a suggestion automatically to security zones and conduits over the environment of that operator, and then have the operator kind of enforcing policies, or policies can be enforced for a product in a way that if there is abnormal communication in one of the rail application protocols between security zones that should not take place, the system will automatically alert on that and help the operator to fix this misconfiguration. And that's something that helped them in order to achieve a sort of a compensating control over lack of segmentation in a specific location, and later on to properly segment their system using those insights and recommendations.
Thanks for that. And on the topic of compliance still, you've mentioned a few times there are standards that are out there for cybersecurity in rail systems. There are standards that are under development. There are standards that are still a gleam in the eye. Can you survey for us what does the regulatory landscape look like for cybersecurity in rail systems?
I think there are a few things to look at, like a few dimensions to look at. One is frameworks versus regulations. The other is the geographical dimension, because different countries have their own regulations. So if we start from the regulatory landscape, so in the US, TSA, with the help of CISA, has published a few security directives that are basically used as regulations. And from what we know, more expected to come. In Europe, the regulations are mostly derived from NIS and NIS2 that cover critical infrastructure in general, and rail is part of it. But part of it is also for the member nations to identify their operators of essential services and kind of identify how can they comply with the overall directives. And this trend of having the regulation part of the critical infrastructure regulation is something that we see in rail, because almost every rail operator is part of critical infrastructure in their country. Other than that, there is the landscape of standards. So the most comprehensive standard that's currently available only for rail is called Technical Specification 50701, developed by CEN-ELEC, and it was published in the end of 2021. And this standard is part of an initiative by both operators and suppliers, mostly from Europe, that have taken the IEC 62443 series and try to identify how rail is different or where rail is different, and developed a sort of like a paper or technical specification that includes the different phases in the life cycle of rail systems and how they should be handled in terms of security. One of the interesting parts, or the unique parts, I think, is the interface between safety and security, which is the topic that is generally in tension. So this technical specification that was released in the end of 2021 served as a basis for another group that I'm actually part of, and it's a group of IEC, which is a global standards organization. And this group took TS 5701 as well as IEC 62443 series, and is currently working together to establish this de facto global standard that can be used by each individual country to align their security within rail systems. Other than that, you have groups like UATP and APTA in the US that are developing lots of useful papers about things like how should you run a tendering process, about maturity programs for railway and transit operators, about OT visibility detection within rail, and all sorts of very interesting topics that I really recommend for anyone who wants to go and dig deeper into the topic to read them and gain more understanding of how the rail environment works and what are the best practices to protect it.
Okay, well, this has been good. Thank you, Mickey. Thank you for joining us. Before I let you go, can you sum up for us? What should we take away from what you've been telling us here?
So thank you, Andrew. So if I could summarize it to a few takeaways, so first is that it's important to notice that rail environments, they have unique nature and they're very evolving in terms of technologies that are being used within them. So that's one thing. The second thing is that in order to operate effectively security within a rail environment, you should really understand how operations in rail work and the different principles around safety. Because without that, I feel like it's very hard to get to proper solutions in securing those environments. And I really recommend to every one of you who are trying to secure them to really talk to your operations people and get more understanding of what's on their mind and what are the risks that they're seeing. The other thing is that a Realtek security platform can really ease your way into securing your environment, and the changes that you need to make in order to secure your environment are not as bad as you might think. And other than that, I just encourage you to visit our website at Silos, so it's silos.com, and we'll be happy to assist you with your journey within rail cybersecurity. We have a lot of experience that I really prefer from others to for others to spur the mistakes that we've seen happening in various places and try to take the shortcut. And we're happy to have you for the journey and help you with our solutions. And of course, please feel free to connect with me on LinkedIn. I'll be happy to chat with any of you on the topic and have interesting discussions about it. And of course, thank you very much, Andrew. It was a pleasure chatting with you today. And I really look forward to more episodes of your podcast. Thank you.
So, Andrew, that was your interview with Mickey. Do you have any final thoughts to take us out with today?
Yeah, one of the insights I got from Mickey was that this industry is much more heavily regulated than I realized.
Yeah, sorry to interrupt you, but it does bring me back to a point that we had thought about earlier in the episode. I think you mentioned that the government has to approve every patch in this industry, which, correct me if I'm wrong, that kind of sounds crazy, right?
In a sense it does, but it's all about safety. This industry from the very beginning, we're talking, I don't know, the mid 1800s or something. In my understanding, this industry has been focused on safety from the very beginning. To my understanding, the telegraph was invented in large part because, or was deployed, continent-wide in large part because of the needs of rail systems. I don't know about Europe, but in North America, most of the track that crossed the continent was single track. You could put one train on it. There wasn't a parallel set of tracks. Except at stations where trains had to get by each other or switch yards. And so one of in my understanding of the history, one of the jobs of the engineer, the person who ran the engine in the freight trains crossing the continent, or passenger trains, if, for example, the train was not scheduled to stop at a station, I was taking the track beside the station, blasting on by, not even stopping. One of the functions of the engineer, one of the roles, was to stick their arm out. There was a boom that swung out with a piece of paper on it. Grab that piece of paper and read it. This is a telegram telling the engineer whether it's safe to continue on the next section of track or not. Or if there's been a delay and if there's been a derailment or something. Safety has been job one in this industry since the very beginning. And it persists to this day. To me, the real challenge that it sounds like is the industry is facing is the dilemma between safety and cybersecurity. In the modern world, cybersecurity is essential to safety. The threat environment is deteriorating. We urgently need to make cybersecurity changes to these safety critical systems that are the rolling stock in our rail systems. This is the dilemma that the entire industry, it sounds like they're struggling with. And, the good news, it's not all bad news. The good news is that folks like Silas are rising to the challenge, and they're coming in with technology and, not just a set of technology, but they continue to develop and innovate as they're participating in these industry forums to, develop solutions that can be deployed against systems both old and new.
Okay, then with that, thank you to Mickey Schiffman for speaking with you, Andrew. And Andrew, thank you as always for speaking with me.
It's always a pleasure. Thank you, Nate.
This has been the Industrial Security Podcast from Waterfall. Thanks to everybody out there listening.